And agent testing is not the same as just basic software testing, right? It's different. You're dealing with a large language model and non-deterministic output. Just so we don't forget, large language models are non-deterministic, fundamentally by nature. And we are trying to put it into a box of some sort with all kinds of constraints, with prompts, topics, guardrails, all of that, and trying to keep them so that they'll do the work we tell them to do, and not do something they're not supposed to do. And here, what you're trying to see is what are the quality issues? Quality as in the quality of the response. Is it accurate? In some case, when it's a simple answer you're getting back, it's like, yeah, you can figure out that it's correct or not. But when it's a summary of something, or you're supposed to write an email where it's responding, how do you know? I mean, you can compare two different emails, and as a human, a lot of times we can say this is well written versus this is not. We have an implicit understanding of how certain emails are written to customers, what amount of detail should be there. But two of them could be equally good and completely be very different, right? They could just have same information. The style might be different. They might be just as good. How do you evaluate all of that? Humans are possible. I mean, you can put humans in the loop and kind of evaluate it. But then you want to do it thousands of times, or even dozens of agents. And let's say you want to do it in multiple languages. How do you scale? Right? That's the challenge. And you want to do it repeatably, meaning you want to do it repeatedly as well, because when you change a large language model, then you have to retest all of that again, right? That's the nature of the game. And these models are constantly changing, as we talked about yesterday. So the foundational thing we have is essentially we're looking for correctness for now. We'll introduce other metrics as we go on, correctness of an answer. Essentially, it's come back with an answer, and we want to test it again and say, is it correct or not? We have a reference answer usually, a question and an answer, and then we're saying what the agent responds with, and we are comparing it to the reference answer, and we are saying, is it correct or not? That's the foundational sort of premise of this. And we'll introduce more and more metrics, more and more types as we go along, but this is the most basic one we're starting with. The simple question, for instance, you take a scenario, there's for instance, a record, you're asking who's the manager, and the expected answer is supposed to be no, David Beckham doesn't have a manager in the database. I'm unable to, there's no manager listed. I'm unable to answer the question. So there's no record. That's what it comes back, pretty much in a similar language. It just asks another thing. Score. So how did the score come up? We'll come to that. This is a correct answer. So we expect automatically the rating to be shown up as, yes, this is the correct answer. And the goal is to do this automatically, right? The judging should be. So how do we judge? We'll get to that. Now, let's say it comes back with an answer saying Beckham's manager is Beckenbauer. If anybody is a football fan, that would probably never happen. But in any case, that's supposed to be Franz Beckenbauer. But anyway, if the old German legend. Any case, it's supposed to be then it will come back as 0, basically saying, yeah, no, this is the wrong answer. There's no manager listed. You made it up. Where it made it up from, I don't know. It knows Beckenbauer generally, I suppose, I mean, in this case. So anyway, that's not important, but it basically came back as wrong. So you have to debug and say, okay, why did it give the wrong result? And we'll provide some tools for debugging all of that. Now, there can be a threshold here. One point is, now, when the scoring is done, it will score it'll score as a floating point number. So you can consider something above a certain number as a correct versus something below a certain number as it's wrong. So that's the basic point of it.
This is a very brief intro to what we are kind of building and launching pretty soon. What we're doing is essentially giving you ability and tools to test these agents. All right. This is not just like your QA testing and so on. So that's different. Our QA also uses these tools. So this is to really evaluate the quality of the agent responses, right? You asked it to do something. is it doing that? Is the answer correct? Is it hallucinating? Is it, is the summary look right or not? So a variety of things, whatever you asked it to do, right? So there are abilities here to kick off an evaluation run, and you should be able to essentially compare two different evaluations. If you're doing two different LLMs, perhaps you want to do not quite A/B testing in the real world, but essentially you want to compare the two, and you'll have those capabilities. Then you should be able to sort of look at metrics like, of course, basic correctness. That's one thing. We have a whole battery of metrics that we look at in the back end, like our data science team also looks at it. But we're going to keep it simple and introduce kind of basic correctness as a simple metric, right? You're looking at whether the answer is correct or not, and however you judge it to be correct. And we have ways of judging it as well automatically in any language if you want, and so on. Like the standard technique that the industry generally uses these days is called using LLM as a judge. Essentially, you use another LLM and ask it to judge the response and how, given a reference response, how good is the actual response compared to that, right? So that's what it's doing. You can also do human corrections on it if you want, meaning you don't think that evaluation is right or the answer is correct enough or it's wrong, really judge it wrong. We provide you tools to override it and so on. We also let you look at, obviously, other things like cost, meaning tokens. How much is it consuming? You want it to be efficient and effective, so that cost is important. You also want the latency. JT was showing, sometimes they do take time to think. Is it taking too long to think? You don't want the user frustration and everything creeping in. It depends on the model. It depends on the task. It depends on your agent design. A lot of factors go into it as well. The same agent can accomplish a lot of things with fewer tokens sometimes versus taking a lot more tokens. So there is a lot of, because tokens are money, right? Ultimately, you are spending, yes, tokens are getting very much more cheaper and everything. And we've included a whole bunch of tokens for you. In fact, if you use Llama and Cohere on OCI, we're not even charging for that. So there's a lot that you can do. But at the same time, you want to be efficient because it drives latency up. A lot more to talk about there. There's agent tracing. In the debug window, you can see a little bit of that, but we are introducing tracing as well. Step by step, you can go through and look at it. Again, we'll go through screen by screen